Okay, good morning, Year 9. I'm sorry I can't give us a live lesson today. I'm in school on the Key Workers rota, so there might be a few of you that I will see about school in a second. So we've got a starter today given on nth term. So this is the use of an nth term sequence for us. And then we're going to be moving on to some work, as a little bit of a review of some angle work so that we're all up to speed and ready to continue with this at a later point. And then obviously going to have higher level work for our Year 9 angle work. So give yourself a few moments to have a look at this question, and then I'd stop the video until you've had that done, or stop the PowerPoint presentation, and then when you restart I'll be running through the answers to this, and there'll be a few points that it'll be useful to do that during the lesson. Okay, I will assume now that you're ready to go through the answers. So we've got an nth term sequence here. It's a little bit more complicated than we might have seen before. So this has got two brackets. Remember, things next to each other in brackets in algebra-wise mean times. So we're looking at times in our two things together. But of course, we've got n plus 1 and then n plus 3. And we need to do our substitutions. So remember, if we after the first term, we let n equal 1. So that's going to give us a 1 plus 1 times 1 plus 3. So that's going to be a 2 times 4, and therefore 8. For the second number in the sequence, we let n equal 2, and that means we're going to have a bracket with a 2 plus 1 in it, and a bracket with a 2 plus 3 in it. So it's going to be 3 times 5, so that's going to give us a 15. And then for our third term, we let n equal 3, so that's going to give us a 3 plus 1, and a 3 plus 3, so it's going to give us 4 times 6, which is 24. So we get 8, 15 and 24. Now it doesn't ask in this question, but we can clearly see here that it jumps up by 7 in this case, and then it jumps up by 9 in the next term. So this is not an arithmetic sequence. This is not one that we would yet to be able to find our nth term for. This is actually going to be a quadratic sequence for this one. And we might see these double brackets coming up later in the course in our algebra work, and we can do things with those. So having a look at the work we've got today, we're going to be having a look at some angles later on in this course. So we need to know and make sure that we've got all of our angle knowledge up to speed before we get on. So for some of us this will be a little bit of revision, for some of us we might find some new things in, but it's important that we can all be capable of this work before we move on. So one of the key things we need to know is that angles around a point add up to 360 degrees. So these 4 angles here, we haven't got them numbered, but because you can see that they make this full circle around a centre point, then they're going to add up to make 360 degrees. This then allows us to do some problems with this. You can see from our learning objectives today that developing students are going to be able to calculate basic angle problems around a point is one of them. Straight lines we'll move on to, and triangles is the last part. Secure students will be able to solve multi-stage problems, so we'll be able to have a look at doing more than one of these angle properties at once. And then excelling students are also going to be able to give reasons. Now, giving reasons, we'll go through as well as we cover these questions, but essentially giving reasons is not the same as giving a calculation for you working out. So if I was to say that A plus B plus C plus D equals 360, that would not be a reason for the working out. The reason would be because angles around a point equal 360. So we've got to measure the difference there. We know that there's not reasoning is not quite the same as showing our working out. So we'll have a look at those in some upcoming questions. So here is a numerical example of this. Now, one of the key things to notice here is that it says the diagram is not drawn accurately. Unless it says specifically that a diagram is drawn accurately, you're not going to be able to use protractors on these, so we need to use our angle knowledge. Now, of course, I've only reminded you of one single angle property, so it's got to be that one that we're looking at here. So the first thing to notice, we've got a squared off angle here, a right angle, so this should be 90 degrees, and then we've got angle Y missing. So it says here, work out the size of angle Y, and this is where we might show some working out. This is where we've got our full circle. We've got angles around a point here. So we've got 360 degrees that they add up to. So we need to remove the ones that we know. So take away 110 degrees and take away 90 degrees, and that's going to leave us with 160. So our missing answer here is 160. Now, in this case, we then need to give the reason, and then we could say that it's angles around a point sum or add to 360 degrees. And that's what we need for this. Now you'll see here that we've got a mark of 2 marks for this question, but it doesn't say that it's 1 mark for the reason and 1 mark for the number of the angle. That's sometimes the case, but sometimes at GCSE they just will not give you any marks at all unless you can give the reason. So it's really important to make sure that reasoning is there in these questions as well at the higher end. And if it doesn't ask for it, then you don't need to, but it's a good habit to always get into for you working out. So the next angle property, angles on a straight line. This is one that you should all remember. I'm going to ask you to have a go at this one in a second. Angles on a straight line, 2 angles together add up to 180 degrees. You should know this because it even looks a little bit like a protractor. We know that goes up to 180 degrees. The one thing people sometimes forget is that it's just the angles at one single point on a straight line. So these 2 angles here. So if I had a really long straight line and it was cut in a couple of places, I've got angle A, angle B, angle C and angle D. Now they're all on the same straight line, but it doesn't mean that this and this all add to 180. It's only at these single points. So this pair of angles adds to 180 and this pair of angles adds to 180. So there's one for you to try. So I'd like you to have a look at this one, and again, if you want to stop the video or PowerPoint presentation and then restart it when you are ready for some answers, that'd be great. And I'll assume you're ready for those at the moment. So work out the size of angle marked W. We've got 2 angles here that lie on a straight line, so we know that these should add up to 180. So I'd need 180, take away 121, and that's going to give us 59 degrees as our answer. The degree looks a little bit low there, the degree sign is in our answer line. Give a reason for your answer. Again, this is not our working out, it's not our calculation. I'll put that in the line above. So the reason for our answer is based on the fact that angles on a straight line sum or add to 180 degrees. So the reason is essentially the angle rule that you are using, and state that you know that. Otherwise they might think you're having a wild guess at what the angle number is. So we also need to remember opposite angles. It's got vertically opposite angles here, but sometimes it's just called opposite angles. Both are used, so a lot of people just go for the shorter version of opposite angles. And this is where we've got 2 absolutely straight lines that cross. So 2 straight lines crossing here and here. And you can see that we would know that A and B together lie on a straight line. So they've got to add to 180, but that's not the problem that we're looking at here. It's at these opposite angles. So A and C, you can see they're both coloured in green, would be the same as each other. And then D and B are also opposite angles because they're straight opposite each other in this shape. They're both coloured in the blue or turquoise colour, so those 2 would be equal to each other as well. And you can say that opposite angles. Now, some people get a little bit confused with these and parallel lines, which is what we're going to be looking at in later lessons. So opposite angles are only when 2 straight lines cross. You can't say opposite angles at any other point. So one for you to try. So again, if you'd be able to pause or stop the video until you've had a go at this question. And we'll assume people are ready to carry on. So work out the size of angle A. Well, it's opposite 104 degrees here. So this is also 104 degrees. Work out the size of angle B. Now, it doesn't matter which way round you go for it here. This could be A and B together on a straight line, and we know what A is. Or you could say that 104, I'll get my pen again, 104 and B are on a different straight line. They'll both give you exactly the same answer. So I'm going to go for this one. 104 and B are on a straight line together here. So we need to do 180, take away 104. And so that's going to leave me with 76 degrees as angle B. Okay, the final variant for our angle problems is angles in a triangle. And we should know this is a really common one, so this is one that a lot of people remember. But angles in a triangle add up to 180 degrees. So we'll have a look at that. You can see this if you actually draw yourself a triangle, and you can actually try this at home if you wanted. If you draw yourself a triangle and put the edges of these angles all together at the same point, you'll get and make a straight line. So it's with absolutely any triangle going. So it doesn't matter if it's a special type of triangle, a big triangle, a small triangle, the angles inside always add up to 180 degrees. So let's put that into effect. So here I've got a right angle triangle. We should know that because it's got the squared off angle anyway. But it's worth labelling that up with what the angle is, 90 degrees. Let's work out the size of angle Y. So we need to know that our triangle adds up to 180 degrees. We've already got a 90 degrees there, and we've already got a 38 degrees there, so take them away from our total, and we'll end up with our final answer for this. So this is going to give us an answer of 52. Again, degrees are on the line there, but they're a little bit low, so it should really be up here. And so that's us done for this question. Now you can also have variants of triangles though, and it's well worth remembering. Okay, so we've got an isosceles triangle here, so it's well worth noting the spelling of this, and we've got isosceles here, and it's got the silent C in it that a few people forget when they're writing this down. This would be really needed if you were writing out a reason for our angles in this triangle. It's not been asked for in this question, but if so, you should write the word with the correct spelling, otherwise you might lose marks on that. So an isosceles triangle has two equal length sides, and therefore it has two equal angles in it. We need to identify where those are. The two equal sides are given with the dashes. So these two sides have equal length, and sometimes we say that the angle opposite them are the ones that are equal. So I've got the side length here that I'm now drawing over in red, and then you can see that opposite all the way away from it is at angle W, and then that means that on the other equal length side over here, opposite that one, will be the same angle. So I'm going to give that a W as well. It says work out the size of this angle marked W. Well, this is where we need to have a think about how this triangle is made. So we've got two equal angles. The angles still add up to 180, and we know we've got 82 at the top. So I need to work out, well, what's left over in the triangle to be made up by these missing letters. So I'll do the triangle total, 180. I'll take away the 82 that we know is there already. So that's going to give us 180 take 82. So it's going to give us 98 degrees. So those two angles that are left over in the triangle here and here have to total 98 degrees. We've just said that because it's isosceles, these two angles are going to be equal to each other. Therefore, I can now do 98 divided by 2, which is going to give me 98 divided by 2. Half of 90 is 45. Half of 8 is 4. So we're going to add those two together. So 98 divided by 2 altogether is 49. And that's our missing answer here, 49 degrees. Now, please do not write your working out like this. It might be how you do it in your head. You might say 180, take 82 is 98, and then a half it to get 49. And 49 is my final answer. This would not give you the correct working out marks in an exam, because an equal sign should link equal things. And 180 divided by, 180 minus 82 is definitely not 49. Right, we now have a mixed problem for you to have a look at. So you might want to pause the video, pause the presentation, have a go at this yourself if you're feeling confident. I'll be running through this either for people that have tried the question or if you need me to walk you through this one in just a second. So we'll assume people are ready for answers to this one. So it says here, triangle EFG is an isosceles triangle. Now remember, we've got the three letters there, EFG. And all that means is if you trace your finger between E to F to G, and then back, we've made our triangle. F, G, H and E, G, I are straight lines. That means if you went from F to G to H, so F to G to H going upwards there, yeah, we've made a straight line, we can see that. And EGI, that's also a straight line from E to G to I under the straight line. Angle EGF is 104, and again you can see this if you trace your finger between those points. Let me just clear the rest of the dots off this problem because we'll be writing some more things on it in a moment. Remember, this angle should be given in its 3-letter notation. So from E to G to F, from E to G to F, you can see that we've only made one angle with my red line here, so it's this angle here. As you can see, it's already labelled up, but just to show how that angle is found. So find the size of angle H to G to I. Well, from H to G to I, I've now made this angle here, where letter G is enclosed. So find the size of that. Well, we've got two straight lines crossing here, EGI and HGF, and therefore we've got opposite angles. So this angle here is also going to be 104 degrees. I'm going to label it on the diagram as well, by the answer line's best. Find the size of angle EFG. I'm just going to pop this in a different colour now. So EFG, from E to F to G, I've now made this angle down here inside the triangle. So this is the one that we're after. Now for this we're going to need to appreciate that we've got an isosceles triangle as given by the dashes there, so we should remember that this angle here is also going to be the same as it. So again, we'd now do triangle angles, take away the angle that we know, and that's going to give us a 76, and that means that this angle and this angle add to make 76, so we're going to split it between 2 because it's isosceles, they're equal. And then again, 70 divided by 2 is 35, and 6 divided by 2 is 3. So add those together, and 76 divided by 2 is going to give us 38 as our missing angle there. And we've done, and that's what we call a multi-step problem. So we've used a couple of angle properties in the same question. So there's the final one for you to try here. So this one's got a couple of triangles overlapping. Now in these questions we might need to see and have a think about different ways of doing them. There's actually a couple of different ways of doing this question. One thing we could do is actually identify that there are 3 triangles in here. You might not need all of them depending on how you're doing this question. So I'd like you guys to give this one a go and then actually run through 2 different ways of getting this problem done. So if you pause the video and I'll run through this in just a second. Okay, now one thing we can do, we need this angle over here marked Y. Now the first thing we need is other angle in this triangle, and we don't actually have that at the moment, so I'm going to consider that we've got a little triangle in green over here, and then we've got another triangle that I'm going to highlight over here in red, and actually you could also treat the whole thing as a big triangle. So I'm just going to draw around in purple as well, so I can refer to either the green triangle for the little one on the left, the red triangle for the one on the right, or the purple one for the big triangle that encloses everything. Now the first thing to recognise is we can't actually get through and get any of our angles in the green triangle. We don't have we don't have 2 angles in order to find the third. Likewise in the purple triangle we wouldn't have all of the angles. We could get the angle at the top here, could actually be 55, but we wouldn't have one down here at the bottom by CFE in order to find out our missing part. So you need to just think about the red triangle here. So the red triangle is isosceles again. We know that because of the dashes. So we're going to be able to do 180, take away the 40, gives us 140. That means that these 2 angles here are each going to add up in total to 140. So we need to split that between 2 to get 70. So this over here is 70, and this over here is 70. Now this is where the problem branches off into 2 different ways of doing it, and we should get exactly the same answer regardless. The one way of doing this is that I could now work out this green angle here. We've got angles on a straight line from D to E to F, so I know that this needs to be 110, because 180 take 70 equals 110. And now I can deal exclusively with the green triangle. I know that the green triangle has an angle Y, an angle 15, and an angle 110. So I could do 180, take away 110, take away 15. We'd get our answer to that. That's going to give us 180, take 110 is 70, and take 15 gives us 55. So y equals 55. Now, from that point of branch, though, what we could have also done is actually dealt with the whole big triangle as a purple triangle. And we could have said then that we've got, in total at the top, we've got a 55-degree angle and a 70-degree angle over here. So I could have said we've got 180 degrees in the big triangle, but take away a 55 and take away a 70, and that's going to give us our final answer to this. Now, that, of course, 180, take 55, take 70, we're still in the same diagram, it's still going to give us another 55-degree angle here. So 55 either way and everything else. Now, of course, you only need to do this once, so whichever way suited you, whether you could see the big triangle there or whether you preferred to do the two smaller triangles, both methods would work, but just be careful with the question later on. It might force you down one particular route. So I'm going to ask you to have a look at some questions here. So there's two activities today for us to have a look at. The first one is just called Activity 1 or Angles Activity 1 in our Learning Cycle 3 Week 6 folder. So choose whether you want the red, amber or green version of it. Remember, the green one is the one with no help. The amber has a bit of help and the red has a little bit of frameworking and support to help you out with those. So you only need to do one of those. And then you can move on to Activity 2, which is a cross number, which I'm just going to show you what it looks like. But make sure you do Activity 1 first, just to wrap up. Okay, so a cross number here, we've got some clues feeling very much like a crossword, but our clues are angle problems for going across or down, and then you'll be able to fill them in on the box. So here, across 1, we've got a missing angle problem. Where we've got A and 18. We know that on a straight line they should add up to 180. So 180 take 18 is 162. So when we get to angle A, this was an across clue, so 1 across is 162. I'll actually get you started with the cross number. Now the answers to this are on the PowerPoint near the end, so they won't be on the video, but if you want the answers, then make sure you download the PowerPoint and check them at the end. So I'll leave you to your independent work. As I say, I am on key worker duty, so you might need to just bear with me a few moments to get back to you on an email, but do please be in touch if you need any support with this. I'll hopefully speak to you tomorrow. Thank you very much and good luck with your work.